Welcome to the session introducing the Parcel Fabric API. My name is Tim Hodson. My colleague and co-presenter is Ken Gallagher. We're product engineers on the Parcel development team. In this session, we're going to show how you can access and use the Parcel Fabric API in pre-release. It's a pre-release version as of 2.5. We'll do a conceptual overview of the information model of the fabric and just the general order of operations of how the system is used. Then we'll get into Parcel Editing API for Pro. And then finally, we'll go through coordinate geometry in COGO and look at things like direction formats and units, grounded grid corrections, and circular arc geometries. So how to access and use the pre-release. To use the pre-release, you will use internal namespaces for the mapping and editing assemblies. And this gives you the opportunity to try it out now and take a look at the API and work with the functions that are available at the moment. Then at final release, you'll remove the internal statement and recompile. Doing a quick conceptual overview. Before you start programming with the Parcel Fabric API, you need to understand the architecture of the system, of the model. So we'll be looking at this diagram in the first few slides here as we go through this overview and cover the different elements of that. First of all, let's do a conceptual overview of the general workflow and the order of operations. The general order of operations follows these 5 basic steps of creating a record objects, creating COGO lines from a source document such as the one that you see on the right, creating parcel seeds for parcels, I'll talk about what those are, and then attribute those and then build the seeds to create complete parcels. When you create a new record object in the fabric, you're really creating the container that represents the legal document. You'll create a record in the records table. You'll give the record a name and the date, the recording date, and various other attributes and properties for that record. And then within that record, we'll add the lines, the record lines that come off the land records document, and those are all contained within that same record within the system. And these COGO lines could be created by just directly manually COGOing in, or copy and paste from CAD, and various other methods of getting these COGO lines in. You then create parcel seeds, as there's a function that will go and look at closed loops of lines and generate a parcel seed inside these closed loops. Those are also polygons. Those are just circle polygons that are inside at the center of each of these closed loops. And then that allows us to go and select each of these seeds and then attribute them with the name and the area, for example, and other attributes that apply to this particular parcel. And then you do that for all of the seeds, and then you build the active record to complete the parcels so that each seed features geometry becomes the final parcel geometry. And also, all of the information that you see created was created within this Northgate Phase 2 parcel record. Under the hood, the geometry of the parcel record is stored and kept as a feature in the records feature class. So if we take a look now at the Parcel Editing API for Pro, it provides a coarse-grained API. So for each of those different 5 steps, there is a coarse-grained single function that allows us to achieve those tasks. It uses and extends the standard edit operations framework, and we'll see a little bit more of that as we go. And then it leverages predefined information models so that we know that every feature class inside the fabric, we know what fields it has. They are required fields, and so they cannot be deleted. And so that when we write code to write to this Parcel Fabric, we can rely on those fields being there, and we don't have to test for their existence. And we'll see some examples of that as well. The editing is based on is a single-use model that works directly on a file geodatabase, but there's also a multi-use environment where the fabric is accessed via services. And because we support a multi-use environment via services, feature services, The API is designed based on a services architecture. And this includes use of the branch versioning model in the same pattern as is used for utility networks, and so operates exclusively within the ArcGIS enterprise. So if we take a look at this slide, this is what you would see if you attended the beginning editing session. This is the workflow for a programmer. They would initially instantiate a new edit operation, specify the edit for that edit operation, and then execute the edit operation. So if we just tag the word parcel on the front before the word edit in each of these cases, this is how the Parcel Fabric API works. So it's just leveraging off the existing framework. So here you can see an example of that. You can see we're creating a new edit operation to create parcel seeds, and that function create parcel seeds is available because we're looking at the internal assembly for the editing namespace. So you access the Parcel Fabric via the parcel layer. Parcel layer has extension methods on it to set and get the active record. The active record is a term that's applied in the context of the client. So in this case, the client being Pro. So Pro has the active record that you can get and set. You'll see that in a second. The thing about the parcel layer is that we can only have one parcel layer per map, and that is enforced by the system. So that if you try to add a second fabric, you will get a message in the UI. If you try to add a second layer via code, you will get an error returned so that you're not able to add a second layer. And this means that when we're writing code to get our Parcel Fabric layer, all we have to do is get the layers as a flattened list from the active map view, and then get the first layer of type parcel layer, and then we know that we will have the parcel layer. And so parcel features are contained by the record, and when we create a record, we are basically just creating a standard feature in the records feature class. So you can create an empty polygon object, and we create a new record in the geodatabase, and then we set that active record to the record that we just created. Parcel Fabric points can be standard points that exist at the ends of every line. If there is no point at the end of a line, then a topology rule is broken and you will get an error feature. And then you're able to fix that error and create points on the end of the line. Points can also be flagged as fixed, meaning that they are control points and used for various purposes, such as in least squares adjustment. So here's an example of creating a fabric point that is a control point. You can see that we've already created a new point geometry in this case, and now we're just going ahead and adding the name for the control point. We don't have to test for the existence of those fields because we have a predefined model. We know that the name field exists, and we know that the isFixed field exists. And we're setting the fixed field to 1, meaning true, so we're saying that this is a fixed point, meaning a control point. And then we run execute on that edit operation to create the point. Connection lines are used for a few different purposes. We can connect from one parcel to another parcel across the road right of way and set that connection line with a value of 60 feet, for example. We can also use connection lines to connect to control points as a tie line. And connection lines can also be used to represent a street center line. In general, connection lines and lines, any lines within the fabric, are COGO enabled. And COGO enabled means that these fields exist on the lines. So whenever a new line feature class is created as part of the fabric, we know that it is COGO enabled, and it has these fields: direction, distance, radius, arc length, and radius too. And these are all double fields. And also you will notice that we don't specify all of the different circular arc parameters. We specify only radius, arc length, and direction. And that is intentional. We don't over-specify the curve, but the other values can be computed on the fly and represented through label expressions, and so on. And also we have radius 2 because we do support spirals as well. So now I'm going to hand it over to Ken, who's going to take it from here and talk about parcel types.
All right, thanks, Tim. So a parcel type consists of simple feature classes, a polygon feature class, and a COGO-enabled line feature class. Each of these is related to the records feature class using created by record and retired by record global ID fields. And the Parcel Fabric can have as many parcel types as needed to represent your land records. Keep in mind, however, that the Parcel Fabric API is a DML-only API. That means creating new feature classes or modifying or extending a parcel type schema must be done with either geoprocessing tools, Python, or the Pro client. But with that said, the Pro SDK has classes to execute geoprocessing tools. So let's look at this in action. So as I said, adding a new parcel type to a parcel fabric results in two new feature classes. So right now, in this simple feature class, I have, or a simple parcel fabric, I have a pair of lots and lot lines. I have this kind of a sample one here, and I also have parcels and parcel lines. So I have, in my parcel fabric, I have 3 parcel types. So let's create a new one here. So we'll give this a name. And then, so this stuff up here is just for the progress dialog. What we're interested in here is creating a list of arguments to pass into our tool. We can do that with the static method on the geoprocessing class makeValueArray. We're going to pass in our parcel fabric layer, which we're going to get from the map. And then we're going to pass in the string I entered in the form, which is our parcel type name. So we'll execute that. Right now it's going to be registered with the topology. It's going to be registered with the parcel fabric container. Tables are going to be created, topology rules, and then we'll refresh our feature data set. And we can see we have our new parcel type. If I add this fabric to another map, we can see our parcel type comes in with the default symbology. It's recognized as a parcel type when the parcel fabric is in the map. So let's move on to record-driven editing workflows. The parcel fabric record is the key to unlocking parcel-specific behavior in a pro or custom application. A parcel record will be present in just about everything that is done to fabric features. So in this demo, I'll create a new parcel record, then add a control point. Then we'll look at the attributes of the point to see its relationship to the record. We'll create a new record. Let's give it a new name. So I'll get access to my parcel fabric layer from the map. I'll do the same with the records layer. Here, we're going to need that access to that feature class, and I'll get the spatial reference from the map. I'll create a new edit operation object. And the important part here is that we're creating a new row in the records layer. So for creating a new parcel record, an empty polygon object is created. Now I want to emphasize empty as meaning there's no geometry to the record feature at this point. The geometry of the new parcel record will be generated at some other point in the editing process when the fabric is built. So there's no need to supply a geometry here at this time. So we'll make sure our polygon is set. We'll create a dictionary to contain the attributes that we want to set. The name field is required, but we can also add anything if you've extended your records feature class. We can add the attributes here. We'll take our edit operation and create an editing command out of it, and then we'll execute that command. At this point here, I'm just double checking that my global ID and object ID fields were set properly for my new feature, and they are. So I'll take those values and create a new parcel record object. I'll pass in the map that we're working with, the new record name, the global ID that we generated, and the object ID. And then I'm going to pass that to the fabric layer using the setActiveRecord method. And what happens when we do this is we see the heads-up display in the map is now set with our current record. So now every Parcel Fabric action that we perform will use this record to inform parcel behavior. So let's add a control point. Again, we need access to the Parcel Fabric layer because in this case, we're going to get out the active record. We're going to make sure that it exists, make sure that active record is set so we're doing the right parcel thing. We'll get access to the points layer. We're just going to grab the center point of the map view. We'll generate a feature from that. Another dictionary to handle our attributes. And so if we look right here, in the case of parcel points, I may want to be deliberate in setting the isFixed value, as this will be evaluated using alignment or adjustment tools. So setting isFixed to true will give me a control point, and leaving it as false will just create a point that we can, like a normal parcel point. So we'll create an edit operation. Actually, let me catch up here. We'll create the command to execute the edit operation, and then we'll execute it. And we can see in the map that we have a new test point. So let's take a look at the attributes of that test point. And we can see here that the created by record value was populated for us. And we can look at the last four of that is 8D54. And if we check the attributes of the record, we can see 8D54 is our record, and we're working off the correct record name. So the created by record ID in the point matches the record information. So I'm going to discard these edits here. And then we're going to look at some bringing lines into the Parcel Fabric. So in this scenario, let's imagine a new deed was created and the surveyor provided some line work representing some new parcel lines. So in this case, I'm just using line features from a FileView database, but you can imagine this would be a CAD drawing, a shapefile, SDE data, any other valid line feature class that we can bring in, we can copy into the Parcel Fabric. So we'll start by creating a new record. It's going to be the same thing we saw before. Create a new polygon, add our values to it, set it as the active record in the map. We have DevSummit 002. And then I'll select some lines. So in the case of the copy lines to parcel type tool, parcel seeds are automatically generated when or where any closed loops are found. So if a set of lines isn't closed properly, the seed won't be created. The editor can review the line work, make a correction, copy the corrected lines into the parcel type, and then create the seeds manually. So in this comment here, I'm just listing out the arguments that we're going to pass into our function. So the source lines layer is the lines that we're copying into the fabric. Further down the line, we're going to grab the object IDs out of those selected features, and then we're going to get access to the parcel type that we're copying into. In this case, our target lines and target polygon. Our target polygon will see the seeds at first. So I'll grab my feature layers from the map. Once again, I'm going to grab my Parcel Fabric layer because I want to get access to the active record. I want to make sure that active record is set. I'll create my edit operation here with my edit operation object. Here I'm going to go into the map and find the selected object IDs of my source lines layer. These are my selected lines. Create a command for my edit operation and execute it. So now at this point, our parcel lines have been created and our parcel seeds have been created. But I wanted to stop here and show that in our edit operation, we chose to select the new features after they were created. We set select new features to true. So what that means is we now have access to the selected parcel lines and the parcel seeds. So you can imagine we can do some attribute updates or other calculations before we return back to the map. I'm not going to do that here, so I'll continue on. I'll zoom in a little. So we can see that we have 2 closed loops in our line selection, and 2 seeds were generated. So we intentionally left this one off just to show the seeds wouldn't be created, but let's show how we can fix that, because we want these 3 parcels. So I can turn my lines back on. I can select that line. I'll do the same exact thing. Keep in mind that our record is still set, dev sum at 002. We just made a mistake that we want to correct, but we're going to stay in the same record. I'm going to copy those lines to the feature type. And again, it's the same thing. I'm going to make sure the active record is there, get the selected ID of that one line that we have, do some attribute updates if necessary. And here we can see we now have our new parcel line, and now we have another closed loop. So I'll just use the standard, the built-in tools to create seeds, but I can do this programmatically as well. Just click the button, and we get a new seed. And that's what we want, because we want these 3 parcels. So what we can do now is we can go and make some attribute updates to the seeds if we needed to. I'm deliberately putting them out of order because I want to show that if you find something going on with your seeds, the placement's not right, maybe you have some complex line work, there's small loops and big loops, or something complex that makes it difficult to see, maybe the seeds weren't placed where you want them to be, we can always manipulate the seeds before we build. So in this case, I'll move this one here. I'll move you back to here where you belong. It doesn't really matter where the seeds are, they can exist anywhere. Let's finish that edit. Great, so now I have my parcel seeds and the attributes are updated correctly. They're placed where I want them to be, so now it's time to promote those seeds to actual parcels. Let's go back into our add-in. So in this case, we want to build the parcel fabric. So we've already seen this several times now. We're going to go in and get the parcel fabric layer because we want to get the active record. We want to check that the active record is set in the map, but we also need to get the global ID out of it. So we want, because we're going to need that. So we're going to create our edit operation, and we're going to use the function build parcels by record, but there's actually 2 ways to build the parcel fabric. We can build by record, which we're going to do here by passing in the global ID value. But we can also build by the map extent. So there's another function just to build the extent. So in this case, yep, we're just going to do the global ID. Let's make sure our global ID is set. That's where we want it. Got the global ID of the record, so we'll continue on. We'll execute our function here, and here we see our 3 parcels have been promoted to parcels. The attributes are where we expect them to be. We have A where A belongs, B where B belongs, C where C belongs. So now let's look at merging parcels. So a similar situation occurs, like a new deed comes in, owner A is going to sell their land to owner B, and this is going to require that the 2 parcels be merged into one. They're tax parcels now, and they're going to be merged into one single tax parcel. So our dev sum at 002 record defined what happened when these 3 were created. I'm going to create a new record because changes are going to occur to these 2 parcels. Excuse me. So same thing, we're going to get our parcel layer, because we're going to check and make sure that's set. Now we're going to get our records layer. Oh, actually, we already went through this, so I'll kind of breeze through this. I'll slow down for the merge. So I have our new record set in the heads-up display, Dev Summit 003. So we decided that owner A wants to sell to owner B, so we'll select those two. And let's begin the merge. Like I said before, we have two tax parcels that we're going to merge into one tax parcel. So I'm going to keep my target parcel type as tax. We can merge them into a different parcel type if we wanted to. So in this case, I'm going to get my source feature layer and my target. So I'm going to get what I selected, what parcel type that I selected, and what parcel type I want to merge into. And as I mentioned, we're just going to the same parcel type, so these are both going to be the same. I'm going to get my Parcel Fabric layer because, of course, I need to make sure my record's set. We're going to continue on and get our edit operation. We're going to get our merge command here. We're going to pass in our source and target feature layers, and then the selection of features that I have in the map. So we'll execute that. And here we can see the two parcels have become one. The active parcel is now merged. But importantly, or important to the Parcel Fabric, is we've maintained the parcel lineage. So we turn the current parcels off. We can see that our original two parcels were not deleted. They were just given a retired by record ID. And when you have features that have a retired by record ID, the definition query of your parcel type picks that up and hides that from you and symbolizes it differently. So we know that our parcel lineage is maintained, and we have our new parcel. Let's turn that off. But what I want to do is I'm going to discard the merge. Let's start back over here. And I'm also going to unset my active records. Now we're working with no record in the map. So as we mentioned before, a parcel type, or the feature classes in a parcel type, are just simple feature classes, meaning that when we edit the Parcel Fabric, we can use just standard editing tools that that we're familiar with: move, split, merge, divide, clip, all those. They're just simple feature classes, so those tools will work. Having the parcel record informs the parcel behavior. So let's take a look at what happens when we try to merge these parcels without the active record. So we'll click merge again. At this point, it doesn't matter what we pick. Here's all the stuff I showed you before, but you might have picked it up as I try to scroll past it pretty quick. I am checking if the parcel record is there, but I'm not kicking you back if it's not. So in this case, we're going to end up with just a little warning saying there's no active record, parcel lineage will not be generated. So we'll go through and execute the merge. And here we can see the outline of our selection looks like the merged parcel that we want. And it's there, but as I mentioned before, parcel lineage is not maintained. So if we look here, we have our new feature. We also have our original ones that look like the current record. So let's go ahead and fix that. I'm going to set my record as active again. Let me search for it here. Dev Summit 03. I'm going to select my other parcels. I have both parcels selected, A and B. I also need to select this line that divides them, or these two lines that divide them. And now what we can do is we can set these parcels as historic parcels. So same thing you've seen before. I'm going to get my Parcel Fabric layer because I'm going to check the active record. A lot of the stuff here that's collapsed, we're just checking to make sure the selected features are indeed parcel features. But what we're really interested in here is, of course, getting the active record, making sure that it's set. And we're going to get the global ID out of that. Let me just continue on so we can see the values here. We're going to get the edit operation. We're going to get the global ID, and then we're going to create our edit operation, and then we're going to call update parcel history. If we pass in the argument of true at the end here, we're going to set them as historic parcels. If we set it to false, it's going to be the opposite. So it's how we toggle on and off historic parcels. So we'll continue on. We see again that our parcels are merged the way we want them to. That was our number 7, I believe was the object ID. Yeah, object ID number 7. But as far as the parcel is concerned, and more important to the parcel fabric, is that we now have our historic parcels. The retired by record is set for both the polygon features and the line features. So in these demos, we've seen the importance of the parcel record, the concept of parcel seeds and how they work in record-driven workflows, and some of the things to look out for when editing with a parcel fabric. So back to you, Tim.
Thanks, Ken. So let's take a look at what's next for the Parcel Fabric API. We're in pre-release at the moment, and let's take a look at what we plan on doing. Here are just a few key enhancements that we're going to be putting in. There will be others. We want to simplify the creation setting of the parcel record object, make that a bit easier and more direct and coarser grained. And also we want to be able to provide more discrete ways of getting the points layers, connection layers, records layers from the parcel layer. And similarly for the parcel type feature layers, we want to be able to get back a list of those feature layers that are for a specific parcel type. Then we also want to be able to query a particular feature layer to see if it belongs to the active maps fabric. And so those are just 3 of the enhancements we plan for the future. Now let's move on. We're going to take a look at the API for the coordinate geometry in COGO. Everything you'll see at this point in terms of the code is released API. So we'll be looking at how to look for COGO-enabled lines, converting direction formats and units, quadrant bearing to north azimuth, and so on. Looking at how to get and set grounded grid corrections and how to use those, and then also creating circular arcs in a COGO environment as well. So we saw this slide before. This is the schema for COGO-enabled lines, and as mentioned before, in the fabric, all lines are COGO enabled. When you test for COGO enabled lines, you are getting the feature class definition, and then on the feature class definition, there's a property that says is COGO enabled, and you test to see for true or false on that. All the COGO enabled lines are doubles. But when presented in the UI, we do have a number format converter that'll take a direction, and directions are always stored in north azimuth decimal degrees for COGO-enabled lines. And so when we present those in the UI, we can have a number format converter that takes the direction in north azimuth decimal degrees and then presents it in quadrant bearing or other formats. That's why when you see these values in the table, those don't look like doubles, but they are in fact doubles. If you click on one of the fields in the table, you can see the underlying value for the direction, again in north azimuth decimal degrees. So we'll use, as an example here, a Travis text file and show how to kind of pass through these files in order to generate COGO lines. And there's also sample code that we will be providing for you to download, and all of the samples and demos are available. The code is available to you. Looking at converting direction formats and units, in this case we see that we have a direction type of quadrant bearing and the direction unit degrees minutes seconds, and here we have an example of a quadrant bearing. We want to be able to convert that into north azimuth when storing in the database, north azimuth decimal degrees. So we show how to do that through code right here. So here's a function. It uses a direction unit format conversion class, and you create an instance of that. And then you define the direction in type, and then the direction in units, in this case quadrant bearing and degrees minutes seconds, and then you define the direction type out and direction units out, in this case, this particular case, polar and radians. This is a function that will be used quite a lot because the geometry engine uses polar radians for its directions. And then you call convert to double, and you pass in the string, and you get back, and you pass in the conversion definition object, and you get back the double in polar radians in this case. Here's another example. In this case, we're going from polar radians, so we're coming back out of the geometry engine, and then we're storing to the database, so we're going to store to north azimuth decimal degrees. When passing through something like a Travis file, you can read through line by line, and when you detect a particular direction type or direction unit, you can set those accordingly. Grounded grid corrections. This is what the grounded grid corrections tray looks like in the UI. You can see that we can toggle the whole grounded grid correction on or off, and then we can individually set to turn on direction offset or distance factors, and specify specific numbers for direction offset as an angle, and then the distance factor as a constant. Looking at this in code, you set your grounded grid via the map view through the sim properties, and you can get the grounded grid correction directly off the map, and then you get a sim object, and then in the case of a brand new map, as indicated in the comments here, you would need to initialize it for the first time, so if it's null, then you can create it. If we take a look at what we're doing here, we're setting a constant scale factor to a particular value, so we want to make sure that we turn on the distance factor, and then we turn on the constant factor, and you can see the equivalents shown in the comments there, what pieces of the UI those represent or are represented by. And then you set the grounded grid correction and pass in that sim object, that new object that you've just set. Reading the grounded grid is actually a lot easier. We do that through extension methods. Similar pattern, we get the sim definition, but then we have extension methods on that grounded grid object that allows us to get the constant scale factor and get direction offsets and so on. And what this does internally is it automatically checks to see if the grounded grid is actually active and turned on, and also checks to see if the checkboxes or the equivalent of the checkbox is turned on, so that it is currently set by the user. And if any of those things are turned off, then the scale factor just returns 1. And similarly for direction offset correction, if any of those are turned off, then the direction offset correction is just set to 0. Also note that the direction offset correction is always stored in decimal degrees. And in this particular case, this little snippet of code, we're converting it to radians for use in circular arc creation, because that's what the geometry engine uses. It uses radians. So for circular arc parameters, these are the typical parameters that we use when creating circular arcs. For the shape and size of the arc, we're looking at combinations of any two of the radius, chord length, arc length, or the delta central angle. And then for the orientation of that curve, we'd use one of those 3 orientation parameters, being chord direction, tangent direction, radial direction. So here's an example, again going back to the Travis file. In this case, we have a radius, a central angle, and a tangent direction. So we'd pass through that file, look for the codes that indicate those are the parameter types for the circular arc, and then construct the circular arc accordingly. Circular arc constructors in the API are done through the elliptic arc segment class and the elliptic arc builder. The circular arc is just a special form of an elliptic arc, so that's why that we can create a circular arc through the elliptic arc builder. And so on the elliptic arc builder, there are a number of overloads. There are 2 or 3 overloads that are specifically about circular arcs, and those are the ones that we would use for in a COGO environment. So in this case, you can see that we're using a chord length, chord bearing, radius, and counterclockwise, so curve to the left, and a major or minor for the circular arc. Now, unlike in ArcObjects with ArcMap, we had a very large number of circular arc constructors. That is not the case with the elliptic arc builder. However, you can achieve all of those different combinations and parameter combinations just using some first principle circular arc geometry. In this particular instance, we're creating a circular arc using a delta, arc length, and chord bearing. So you can see that we can get our chord bearing just by looking at the radius and arc length and delta and computing it, and then passing that into the constructor for the circular arc. And here's another example. In this case, we're looking at the radial bearing and getting a radial bearing converted into a chord bearing. And so all of these different parameter combinations are available in the construct from file sample, which I will also be demonstrating later, and that you will have access to through the download. So now let's take a look at a demo showing how to use these various pieces and put them all together. Okay, here I'm working with the same demo project that Ken was using earlier. I have a couple of maps, one with some Polk County data and also some with some Clackamas County data. I'm showing some spirals that we'll also be using in this demo. There's a scan image which has been georeferenced. This is the Northgate Phase 2 little subdivision. Nice one to work with. These orange lines are just some source data, but I also have a fabric in the map, as you can see. Currently no active record. Here's the add-in with some tools that Ken showed earlier. And here's a tab with the add-ins that I'll be showing. In addition to that, I'll also be using this construct from file add-in. But just to start with some of the basics, first thing I'll do is create a circular arc and jump into some code here. This works off a selected line feature layer in the table of contents, so I'm getting prompted here to do that. So I'm going to go ahead and choose to add a circular arc to my connection lines in the Parcel Fabric. So I've hit a breakpoint here. In this case, we're presenting an example scenario where we're making a circular arc that has a 30-meter radius and 30-meter chord length, and with a tangent, with a chord bearing of north 10 degrees east. Here you can simulate some user-entered values. We've got a radius of 30 in meters, chord 30 in meters, and then quadrant bearing and a string value showing that quadrant bearing format, which we'll be converting. And then this is a curve that'll go to the left. We are going to be using grounded grid corrections. One has not been set at this point. So if we skip through these pieces, you can see that a grounded grid is actually null at the moment because one hasn't been set. And the scale factor is 0. And let's see if we skip over here. We're using the extension method to get the scale factor. So because nothing's been set, it's just going to default to the scale factor of 1. And then similarly for the direction offset, we skip over this. We get a default value back of 0. Now the other aspect which we need to talk about here quickly is that we want to be able to convert our units, metric units that were coming in, into the linear unit of the projection of the data set. So we go get the feature class definition, we get a spatial reference, and we get the unit conversion factor. That'll give us a meters per unit value. And you can see here we're going to feet. And so we're going to convert, we converted our radius and our chord into feet, from metric to feet. And then what we're also going to do is this conversion, we're going to take that quadrant bearing string value and convert it into polar radians because our curve constructor will be in polar radians. So we jumped over that. You can see that now that is in radians. Now we know that we're going to the left. Curve left is true, so our counterclockwise value is going to come back as counterclockwise. And then we're going to multiply by our grounded grid factor, but of course in this case those are just 1 and 0, so we can skip over that. We're going to default to our start point as being the center of the active map. And we're going to go ahead and use the elliptic arc builder and create the elliptic arc segment, which in this case is going to be a circular arc with our start point, chord distance, chord bearing, radius, and so on. And then finally what we're going to do is write those COGO attributes that were user entered onto the COGO fields. Now it's important that the values as entered are entered into the system, but also that those values are in the units of the underlying projection. What we're going to do here is we're going to reverse or back out the grounded grid corrections with the direction offset, but we're not going to convert back to the original distance unit conversion because we want to keep that attribute value in the units of the underlying projection for the COGO attributes. Recurving to the left, here's another example when we don't store specifically as the COGO attributes to the left or the right. The way that we represent that is by a negative radius. So here we're just converting this radius to a negative radius because we know that we're curving to the left. And now we're going to add to our attribute list. So we know that because we COGO enabled that we have a radius field and an arc length field. So we're just going to write the radius field. And then we don't, as I mentioned before, we don't store all of the parameters of the curve. We just store the radius and arc length and chord bearing. In this scenario, we're taking the computed value for the arc length and we're getting that from the computed circular arc. And then we're backing out the scale factor. In this case it's 1, so it's not going to change. But we are going to then write that in as the COGO attribute. Then we create our edit operation and go ahead and create the curve. Here you can see we have our curve, and if I do a quick peek at this, we can use our on-screen constraints, just take a look and see what we have. So you can see that we have our north 10 degrees east, and then our 98.43 feet, which is the converted from metric value of that chord distance. And then the labeled value is the arc length. You can see we have our radius and arc length is 103.07. And that's what gets stored on the COGO attributes. If we take a look at that quickly, you can see that we have our radius and arc length and our direction as quadrant bearing. Now what I'm going to do is I'm going to do that same curve again, but this time I'm going to apply the grounded grid correction, which I happen to know for this data. I'm going to go ahead here and click Set Grounded Grid, and we're going to hit another breakpoint. Here we have another add-in, and in this we're specifying our direction offset correction, and this is always stored in decimal degrees irrespective of the project unit settings. So I've hard-coded it because I know what it is, but of course if you were to write a proper add-in to do this, you would have a dialog and so on that entered these values. As before, we're getting our map view and then we're getting our grounded grid value, and we set it as a new one because it starts out as null for new map, so we initialize it for the first time at this location. Then at our breakpoint here, we're going to turn on the overall grounded grid correction. We want to use the direction value, so we're setting these values directly, and you can see again here, as I showed in the slide, these correspond to specific elements in the UI, and I'll show that setting in the UI in a second once I've run through these. And then we're setting our direction offset, and in this case our scale is going to just stay as 1. So I'm just going to skip all the way down to here, jump over here, We've set that to 1. And now we're going to set our new ground grid corrections onto that sim property onto the map view. So now if we take a look, we can see here that we've got a ground grid has been turned on, and our direction offset is, this is showing it in degrees, minutes, seconds, so it's the UI is automatically converting that for us. So that's -1 degree, 59 minutes, 10 seconds, and our constant scale factor is just 1. Now I'm going to go ahead and create the circular arc again. We're going to go skip all the way through to here, and we're going to take a look at our direction offset correction. You can see that we have this value, and now we've converted that to radians in this case, because as I mentioned before, our geometry engine uses radians. Now I'm going to jump into this code and just I skipped over at that time. We're going to go take a look at the function real quick to see what it does. It's coming in as a string, and we're using our Angular direction unit format conversion class, and creating a new instance of the conversion definition, specifying the input and outputs, and then getting back those values. So if we go back here and step into our code again, this time round we're going to convert our chord bearing, which we've already converted over here, but we're going to add our correction offset to it, so that we're going to correct for the grounded grid. And then once again create our circular arc, and then as I mentioned before, we're going to write the COGO attributes, but this time around we're going to back out what our chord bearing was, and then we'll see the effect of that in a minute here when we look at the curve. So you can see that the selected curve is the newly created one compared to the original one. You can also see that our grounded grid is showing up on the heads-up display because we've turned it on. If we go and do the same thing as we did before and take a look at our corrected bearing, you can see that we have, as we would expect, north 10 east for the selected line, and the little icon is indicating that sure enough the grounded grid is actually in effect at this point. And then also no change to the actual COGO values themselves. We'll go and zoom in a little bit. We can see that on the label here that those are identical. So this is what we expect to see with COGO data. Okay. Putting all these things together, I can show the construct from file add-in. What I'm going to do is just turn off the grounded grid for a second here. And then I'm going to click on this, and all of this data is available to you, including these files. If I now go and select these Travis files, add them to the map, and then compare with our image, things are looking a little bit off because we didn't have a grounded grid applied. You can see each of those Travis files came in, but they don't align up. And also, of course, those went to the connection lines feature class, so we don't really want that, so we're going to undo that. And then choose lot lines instead. Set our grounded grid to our value that we want. You see that we've set it. And then putting it all together, I'm going to go over here to our add-in fabric and create a new record so that we have an active record. Northgate Phase 2. I'm going to go ahead again and construct from file. Choose our files. and this time round they come in with grounded grid applied, and we can see that they line up with the underlying scanned imagery. And then I'm going to use create parcel seeds. And it's asking me to select the target, so we're going to go into lots here for lot lines, create the parcel seeds. At this point I can interact with these seeds and do what I need to with them. Let's say, for example, I might not want to build this particular parcel, and then I'm going to go ahead and build parcels. Then related to that, let's say I wanted to construct this parcel over here. I can go back to my add-in and construct from file for this one, and that loads that in. So that add-in will work also to target polygon features. We can confirm that everything's in that same record. So everything I did was just through the standard editing API, except of course for these create parcel seeds and build. But everything else that I did with these two add-ins here and the construct from file, all of those are just standard API, not specifically Fabric API. However, I've noticed that because I had a target record, that everything went into that record. So if we turn on our Fabric here and turn off our lots, build active, you can see that we get our underlying record showing up. And we can also show that if we show only active, in this case you can see that we have a new record, and because we have chosen to show only active, those aren't showing up. And set this one active again, that shows up. So we know that all of those features, new parcel features, went into the Northgate Phase 2 record. So now I'm going to take a look at spirals for a second. We do support spirals now as of 2.5, the creation of spirals, and so these are all spirals. And as I mentioned before, we have a radius 2 field. If we take a look at this, for example, we can see, I'm just going to clear this, we can see that we have a radius 2 field and a radius field, and the radius of 0 means infinity, so we're going from infinity to a radius of -1432, so that's curving to the left. And then what the add-in will do is that it will allow us to create a station and offset, so it will go along the spiral a certain distance and then create 100-foot left and right offsets. And of note in this case is that with the spiral is that if you look at the vertices, this is actually a densified polyline. However, from a COGO point of view, it is a true spiral because we've stored those COGO attributes. So when we go station and offset and we're finding a tangent and a station and offset for along a spiral, it's not going to sit exactly on the geometry itself. It's going to be a little bit offset because we want to work off the mathematical version of the spiral. We can show that here. So if we go back to our add-in and click the spiral tangent at given length add-in. So here we're just getting our connection layer, so we're just writing straight into the connection layer, so that's just hard-coded. Just a quick way to get the feature class we're looking for. And then also here we're just making sure that there's just a single feature selected, making sure that this is COGO enabled. And then we're getting some user entered values, so hard-coded left and right offsets of 100 feet, and the distance along is just 300 feet, so I can choose any number here. In this case, I want to go along this spiral, so we're going to go 300. And then we're going to construct a in-memory version of the spiral, so that we can, and we'll do that from the actual COGO attributes themselves. So that's what we're doing in this scenario, and we're checking to see if any of the radius values are 0. In this case, our start radius is 0, so we're going to set that as positive infinity, and the end radius is not 0, and so we're getting these directly out of the attributes. And then similarly, we need to look at the spiral stores, in the COGO attribute stores the chord bearing. So we're going to grab that out as the chord bearing. And here's the actual creation of the spiral itself. So it comes off the polyline builder. And the polyline builder has a lot of overloads on it, and one of them being creating a clothoid, which is a spiral. And so it allows us to enter these values in polar radians and so on to construct the spiral. And so we're returning a tangent direction for this spiral. Stepping over this. And then running through it, we can see that at 300 feet, we have created a point on the mathematical version of the spiral. So you can see that that's offset from the densified version of the spiral. The spiral's densified. And then we've computed the left and right offsets for 100 feet left and right. And then the 90-degree forward tangent, that is 90 degrees off from these two lines. So now we're going to step back into our slides, take a look at the Parcel Fabric resources for API. There is a Pro Concepts page that you can get to from this link, and this goes through a lot of what you've seen with the first section of slides and what Ken demonstrated, and that includes some pro snippets. And then there's also a Parcel Fabric pre-release API reference, and you can go to that link, and you can go down to a section called Assets and download a CHM file at the pre-release version. And then the add-in sample code from this presentation is all available. You can scan this QR code to get to that location, and then you should find a folder called Introduction to the Parcel Fabric API, and from that you can get the data that you've seen today, also the code, and also this set of slides. You can also ask questions on GeoNet. So thank you very much for watching.